Good afternoon. It's an absolute pleasure to be with you here in Helsinki. I'm delighted to be talking to you. I'm very conscious of the fact that I'm all that stands between you and a well-earned cocktail or a glass of beer. So I'm going to give you a quick 20 minutes tour of some of the things that IBM is doing in the Internet of Things space. We have the great good fortune to be working now with about 6,000 organizations on Internet of Things projects. As you might expect, we work with the largest corporations in the world, but we also work with some of the smallest organizations in the world and some of the newest IoT startups. And I feel like, as I was thinking about what I was going to say, their stories are the most interesting ones. So I've picked 3 or 4 great client stories to illustrate some of the awesome things that are happening in the Internet of Things today with artificial intelligence, Watson, and other technologies. The second thing about, as I was thinking about what I was going to say, is that when we think about the Internet of Things, particularly those of us in the technology community, we get incredibly excited about it. And we use really big numbers to explain what we're talking about. We talk about the billions of connected objects. We talk about the trillions of dollars of economic value that will come with the Internet of Things. Companies like IBM talk about the $3 billion investment we're making in the IoT space. It's really impressive stuff. But the interesting thing and the cool thing about the Internet of Things is that it comes down to everyday objects that we all use all the time. And those objects are changing the way that we live, the way that we work, and the way that we play. And so as I think about the customer stories I'm going to tell you this afternoon, the client stories, I'm going to do it around 3 kind of everyday objects. The first is a steering wheel. The second, some ball bearings. And the third, a mango, rather oddly. And I have with me a visiting guest star, a real live Finnish mango, or at least a mango that I bought in a supermarket in Helsinki yesterday. More on the mango later on. So let's begin with our steering wheel. And what's the story around the steering wheel? The story around the steering wheel is a story about how the Internet of Things is changing the way we engineer, the way we design, and the way we develop products, expecting a world of ubiquitous connectivity. And like the other 2 stories I'm going to tell, it's a story about how the Internet of Things is making us change a lot of our assumptions. The steering wheel is actually this very symbolic object if you think about what's happening in the world of automotive at the moment. Car makers have assumed for a very long time that cars actually will have a steering wheel. And of course, in the future, they very well may not. We also assume that the steering wheel is the primary interface that the driver or the operator of a vehicle has with the car. Well, that assumption may not be valid for very much longer. Also, in the way that we've made cars, the big car makers have assumed that they will imagine a car, they will think about the requirements for that car, they will design the car, they will test against those requirements, they'll make the thing, and then they'll sell it to us, and they probably won't see too much about that vehicle again. And then in 5 or 6 years' time, they'll spend another few $1 billion, and they'll do exactly the same thing and make us another car that we all buy. Well, those assumptions are changing. Let me play a quick film of one of the clients that we're working with, a really small company called Local Motors, based just outside of Washington, D.C., and see how they're using some of our technology to help overturn some of these assumptions.
Hello, my name is Ali, and I'm making history. I am the first cognitively enabled vehicle. I seat 12 passengers, and you can ask me anything. I'm what's next in automotive innovation. I come from J&D engineers at Local Motors.
Local Motors is a technology company that it's here to revolutionize a 120-year history of the way that vehicles are made.
I still remember the first time someone told me about Local Motors and they said, well, we have a 3D printed car. And then I saw their vision in projects like Ali.
You're going to see this shift. You're going to see the vehicles become more highly automated, ultimately autonomous. You're going to see vehicles become cognitive. And so Watson IoT Auto Lab is very much around the future of that cognitive experience.
And the best part, this is just a start. I'm about to go global.
It was very exciting to us when IBM approached us and said, could we partner with you in putting Watson IoT into one of your vehicle sets, and could we do it quickly?
And you have to be able to ask questions. Just like my passenger asks me, are we there yet? You can ask Ollie these same questions.
The world of IoT is moving at lightning speed. The only way to stay ahead of that game and to be a player in that game is to be able to innovate as quickly as possible, be able to assemble and deploy solutions as quickly as possible, and that's what Local Motors is trying to do, and that's definitely what IBM Watson IoT is doing.
Well, so long for now. My name is Ollie. It was sure nice to meet you.
Okay, so there's a very cool example of an upstart technology company making a vehicle using artificial intelligence to change the way that we as passengers in the vehicle interact with it. It's a great story. But where I think it gets super interesting is if you look at an example of a mature automotive company. We get the opportunity to work with most of the big automotive companies. And I want to talk a little bit about what we're doing with General Motors. Hard to find perhaps a more different contrast between General Motors and Local Motors. Let me give you some facts about General Motors. General Motors last year sold just over 10 million cars in the course of the year. 10 million vehicles, right? That's obviously a huge number. Each one of those vehicles has, on average, 30,000 physical parts in it. Each car has about 50 electronic control units inside it. And each car contains now about 50 million lines of code. 50 million lines of code is roughly the amount of code that's in Facebook or the amount of code that's used to power a modern operating system in your laptop or your Apple. So these are extremely complicated machines. General Motors has 30,000 engineers around the world developing and designing these products. And of course, those 30,000 people aren't all sitting in one place. So how on earth do they do this? How do they pull this off? And how do they manage this change that's happening to their industry? How does IoT help them? Well, in 3 areas. Firstly, they're using IoT technology for engineering, I think rigor is a good word, and engineering discipline, and engineering agility and flexibility. I don't think when people talk about IoT, they talk about the role of the engineer enough. The role of the engineer or product designer is changing so profoundly with the Internet of Things. And this step of engineering discipline is one that many startup companies actually don't take seriously enough. We've probably all read in the press over the last 12 months or so about in-home connected thermostats that break. Or there was this amazing example in the US last summer of an automated pet feeder that broke down. And of course, people use automated pet feeders when they go on holiday. So it's not very helpful if it stops working. These are software problems that are making connected objects not work properly. What General Motors has to do is figure out how to understand the 30,000 components in a vehicle, the 50 million lines of code in the vehicle, and the electronic systems in the vehicle, and bring all of that together in a way that they can manage and in a way that they can reuse. Of course, they're always reusing across vehicle platforms. So they have a project with us called Global Configuration Management, where they're able to piece these 3 elements together in a way that is actually independent of each individual vehicle, so that the engineers working on these projects can take fully baked cases of requirements and test data that they can then reuse on different models and different versions of the products that they're making. So to begin with, engineering discipline, engineering rigor. And if you're a new company in the IoT space, don't forget it. Your products will break if you don't do it. Second thing that we're doing with General Motors is designing for new business models. We've heard a little bit about this already today. General Motors has a product called OnStar Go. They've embedded our Watson artificial intelligence technology into their existing OnStar system. What this means is that you can now communicate very easily with your car using voice, just as we saw in the example from Local Motors and Ollie. But it also means that as a passenger in the vehicle, if you opt into the services, then Watson will learn about you as an individual. Obviously, it will learn about your location as well, based on where the vehicle is. And now you can use the OnStar service to make transactions. It will give you recommendations. You can buy coffee, and you can use your car as a payment mechanism, for example, all using artificial intelligence algorithms baked into the design of the vehicle and how we interact with the vehicle. And the third thing, of course, is about being able to continuously improve your connected product over time. Again, this is where the role of the engineer is so important. Historically, engineers were right at the beginning of the product development process. They design the thing and then say goodbye to it and never see it again. But now, of course, with universal connectivity, engineers can understand exactly how their products are being used everywhere. And then they can update the cars as well. We've seen stuff about Tesla this afternoon. Tesla's a great example of an organization that's using over-the-air updates to change the software in their vehicle to improve it. And over time, they'll be able to use that same technology to personalize the vehicle to the driver and to where you live and how you use your car. This change of connectivity, of course, universal connectivity, is not just impacting car makers. Here are some of the other people that we work with. This idea of over-the-air updates and continuous feedback on how people use your products, I think, is hugely important in consumer electronics as well. Think about the washing machine that you have at home. Now, I know when I do laundry and go and use my washing machine, I think I use 2 settings on the washing machine, and I've got this beautiful Bosch washing machine. I bet you that thing does 100 things, right? And I've never taken the time to learn it. I'm not that interested. But for me, if it'll make my clothes clean, that's all I care about. Now, if you're an engineer and you have now a connected product, you can learn, you can understand how people actually use your stuff. And you can design easier interfaces to those products. You can simplify the functionality of those products. Other organizations, too, are embedding artificial intelligence into the things that they make. Harman are embedding Watson into speakers and deploying it in hotel rooms and hospital rooms. Panasonic have built something we call a magic mirror with us, where they're deploying those in hotel rooms as well, where you can go to your mirror and you can talk to the mirror, and you can ask it if you're the fairest of them all. No, actually, you can't do that, but you can ask it about the restaurant, in the hotel, you can ask it about the surroundings, and you can have a dialogue with the mirror in your hotel. Just finishing off here around engineering excellence, look at a couple of the names on there. Airbus, Raytheon, who obviously make missiles. They're making products that can't go wrong, right? An airplane we expect to work all of the time. It's not like an automated pet feeder, but it's a good example of the need for engineering rigor and discipline in Internet of Things development. Our second story is about ball bearings. And here, we're not talking about how we engineer and develop products. We're talking about how we operate products and how we make products, actually, how we manufacture products and keeping factories working in the whole world of Industry 4.0. And again, there are some assumptions here that are being challenged. We assume that the components that are useful when we're operating a product, like ball bearings, for example, are stupid, right? That they actually aren't connected, they don't have intelligence. And although we're learning that now some of these sub-assemblies can be connected, we're not, frankly, very good at using the data or applying analytics to the data that comes off them. We work with an oil company, for example. An oil rig might have 30,000 sensors on it. The reality is that most oil companies are using very, very little of that data to improve the availability and the uptime of their operations. When you think about things like maintenance as well, still, most organizations perform maintenance on assets based on when the manual tells them to do it. Every 6 months, you go and you visit the machine and you do these 5 things to it. That's how we've always done it. And that assumption, of course, is no longer valid. Let's look at one quick example of this.
Hey. Pass, please.
I'm here to fix the elevator.
Nothing's wrong with the elevator.
Right,
But you want to fix it.
right.
So who sent you?
New guy,
What new guy?
Watson.
My analysis of sensor and maintenance data indicates elevator 3 will malfunction in 2 days.
There you go.
Still need a pass.
So a lovely little story about a big Finnish company who is really exemplifying what it means to transform their operational processes and actually differentiate themselves through operations. Just as we talked about General Motors and 3 ways they're doing that, let's talk for a minute about Kone and how they are transforming operations and differentiating through operational excellence. To begin with, it comes down to the example that we just saw in that cute new Watson advert, where Watson rather smugly has requested maintenance for one of the elevators. It comes down to using the data from these connected devices. It's not about going to maintain them because the manual says that you do it every 3 months. It's about using the connected data, performing analytics on that data, and understanding that a machine is likely to break down at a certain point in the future. We do this with elevators, with escalators. We do it with manufacturing facilities as well to ensure uptime and continuity of manufacturing processes. The second thing Kone is doing is they're using artificial intelligence to actually improve their whole operational performance around how their engineers work. So they're using artificial intelligence to begin to inform their engineers how to deal with problems they haven't seen before. They're also using artificial intelligence to help their customer service agents answer and deal with customer queries better. And they're integrating Watson IoT directly with Salesforce, which I think is a very cool coming together of the connected world and the whole customer service experience. Finally, what Kone, I think, is doing really well, and very interestingly, is they're making that transformational step, right? They are differentiating their entire business based on operational excellence, which for them means introducing new services. It means thinking about, as they call it, people flow. And the whole idea that when you walk into a building, the building knows that you're there, knows it's you, recognizes you. The security gate opens, and the security gate is synchronized with the elevator in the lobby that will take you to your office and where you want to go. It knows that ahead of time. The experience becomes personalized to you. The information screen that you have in the elevator is giving you information that's relevant to you and the experience that you're going to have in the building that day. This is all about offering very, very personalized services. Again, all building on that foundation of data and analyzing data and then building these services that personalize the experience for the user. Kone is one example. There are many, many others. Retailers doing this. Schaeffler, the German engineering company, who has built intelligence into their ball bearings to understand the effect of vibrations on high-speed train networks, for example. So all sorts of organizations now taking IoT and operations seriously. What do all these organizations have in common, General Motors or Kone? Well, they begin with a platform. They begin with a platform, our platform, hopefully, but they are connecting devices to this platform easily and quickly and in a very, very scalable way. Kone services over 1 million elevators and escalators a year, so that's a lot of things to connect to an IoT platform. Secondly, they are applying business logic to that data. They are working on applications to help them manage the engineering process and manage the process of asset management and asset maintenance. And finally, they're all doing this in the context of their industry. They're all using their unique industry experience and their unique industry positioning to help them differentiate, to help them imagine the new services that will be their revenue in the years to come. Our last example, this is where the mango comes in. So I bought this mango yesterday, and it's funny that we in the developed world, in the Western world, completely take it for granted that in a place like Helsinki in April, you can go and buy and eat a mango. We utterly assume that, right? It's an everyday thing. This mango was grown in Peru, so it's traveled nearly 12,000 kilometers to get here. It's extraordinary when you think about it. We assume not only is this product available to us, we also assume that it's safe to eat, right? We don't even think about it. And yet, think about some of the food scares that we've had over the last few years, and not just scares, real events. We're working with Walmart now in the US, who serve, 250 million customers a week, to help them track the mango supply chain. So how does a mango get from Peru to here? Well, it starts off, obviously, on a tree. It takes nearly 8 years for a mango tree to be productive. So a long time ago, this tree was planted and has been looked after by somebody. The mangoes are picked before they're ripe. They're taken to a processing facility locally where they're washed. They get shipped across a border, and they arrive in another processing facility. There, they get washed again. Sometimes then they get peeled and they get cut up, and you get mango, pre-packaged for you, so you don't have to go through the effort of doing it yourself. Then they get shipped to a distribution center for a retailer. From that retailer's distribution center, they go to a store. From the store, they get put out on the shelf in a refrigerated unit, and then we come in and we buy it and take it home and eat it. Now, so that's a complicated journey, right? That's a really complicated journey, and it's hard to figure out what's going on in that journey. A few years ago, there was an E. coli outbreak in the US, and it was traced to spinach. A couple of hundred people were infected with E. coli. Now, if a couple of hundred people are ill enough to go to the doctor or go to the hospital and get diagnosed, probably several thousand people were impacted. 30 people suffered significant organ failure as a result of the outbreak. 3 people actually died. What was the result? What happened in the US? All spinach was removed from sale, as it should be. You couldn't buy it in the supermarket. You couldn't get it in a restaurant. But it took over 2 weeks to figure out what was going on. So this industry was completely decimated for several weeks while the authorities tried to work out what had happened. They found out that the problem came from one supplier, one lot on one day. So a very, very localized problem. But it took them weeks to figure it out. What we're doing with Walmart is using the blockchain with the Internet of Things to understand how products move through their supply chain. And the blockchain is an incredibly useful technology for us here, combined with IoT. Because what the blockchain is a distributed, secure, and unalterable ledger of transactions. So when you think about how supply chains work today, you've got ERP systems, you've got people making phone calls, people sending text messages, people using paper as stuff arrives in one warehouse and goes off to another one. It's really hard to see what's happening. But with the blockchain, we can, in a decentralized and totally secure way, understand the movement of products. And we do that by linking sensors to the blockchain. I've got a sensor here that's a prototype of one that we're using as part of the Kino consortium here in Finland, in the city of Kouvola. I hope I said that right. But in Kouvola, there's a big transportation hub, and they're using sensors just like this, tied to the blockchain, to manage logistics and the tracking of shipments. And what happens is, when this sensor gets moved or hit like this, the record of that happening goes immediately to an enterprise-grade version of the blockchain. The sensor also can measure temperature. It can measure whether a container door has been opened or not. So you can see how a sensor, coupled with a technology like blockchain, where all parties can instantly see what's going on, can completely change how visible products are as they move through the supply chain and how we trace them. It's not just supply chain. It's useful for things like parts history and understanding the validity of parts. Does your General Motors car have any bad parts as part of its 30,000 parts? And it's useful for things like metering. Think about smart meters, where you can embed this technology directly into the meter to understand how people are consuming a service. So that's the end of our journey. Why are so many people working with us? I mentioned we had 6,000 organizations, clients, and partners. They're working with us because they need a platform. They need a platform that they can connect to super easily, but that will scale in every single country that they work in. They work with IBM, frankly, for security as well and for trust. We're not going to sell people's data. We're not going to do anything bad with people's data. Keeping IoT data secure is a huge priority for many of these organizations. And as you've heard, they're beginning to apply artificial intelligence and other kinds of analytics to that data to allow them to expand and do new things and offer new products and services. So there's our story, the steering wheel, a ball bearing, and a mango. It sounds like a joke, but it's not. Together, they are changing the world we live in. Thank you very much.
Thanks a lot.
Of course.
So what happens to the mango now?
Well, we can go and eat it,
Are
actually.
you
Come
going
over
to
to the
put a
IBM
sensor
booth.
on that?
Yeah, we'll have a healthy snack.
Okay, before you have a cocktail. What's the future of these?
These are
Yes.
going to be deployed in Kouvola. Am I saying it right?
Yeah. Yes,
It's
Kouvola,
hard to
yes.
say. I wanted
Yes.
to learn a Finnish word, actually, so I decided to learn the Finnish word for mango.
Kouvola, yes.
But it's mango, so it
Yeah.
didn't get me very far. Anyway, so these are being deployed at the logistics depot in Kouvola right now, actually. We're doing the proof of concept now. And the idea is that the parties that come together in that supply chain consortium will all immediately be able to see and understand how the goods and services are moving through that facility, that place.
How important do you think is that we are able to, track and trace practically everything in the
It's
world?
incredibly important. It will save us billions of dollars, I think, in efficiencies, and it will make us more certain about the products we're using, the food we're eating. It'll give us that sense of certainty and security that we kind of take for granted and can't always do.
All right. Thank you very much.
You're welcome.